When pilots talk about the most powerful planes in the sky, the Boeing 757 often tops the list. Known as the sports car of the sky, it's famous for its rapid acceleration and impressive climb performance, thanks to its exceptionally powerful engines. The 757's ability to thunder down runways and reach cruising altitude in record time has earned it a legendary status among aviation enthusiasts and professionals alike. But when the conversation shifts to the most underpowered aircraft, the Airbus A340-300 frequently gets mentioned. This massive plane, with engines that seem too small for its size, takes a much more leisurely approach to getting airborne. While the 757's engines might be considered almost too powerful, the A340-300's engines are undeniably too small, leading to extended takeoff rolls and slower climbs. Why did Airbus equip such a large aircraft with relatively tiny engines? Join us as we dive deep into the intriguing story behind the A340-300's unique design and discover the reasons behind this seemingly odd engineering choice. Welcome back to our channel. Today, we're going to delve into the fascinating story of the Airbus A340-300, an aircraft often criticized for being underpowered. The A340-300's performance is a stark contrast to the highly praised Boeing 757, earning it a reputation as a lumbering giant. Despite its size and range capabilities, the A340-300 struggles with its relatively small engines, leading to questions about its design and performance. In this video, we'll explore the reasons behind Airbus's decision to equip this massive plane with smaller engines, the implications of that choice, and how it impacted the A340-300's legacy in aviation. Let's get started. To understand just how underpowered the A340-300 is, we need to delve into some key performance metrics. When we compare it to the Boeing 787-9, which closely matches its range and capacity, the differences become stark. The A340-300 is approximately 11 tons heavier when empty due to its aluminum construction, whereas the 787-9 benefits from lighter composite materials. This weight difference already puts the A340-300 at a disadvantage, but the real issue lies in its thrust output. The A340-300 produces significantly less thrust, resulting in a thrust-to-weight ratio about 10% lower than the 787. This disparity is evident in real-world performance. The A340-300 typically takes around 10 seconds longer to lift off than the 787 and requires an additional 1,100 feet of runway. Moreover, the time it takes to reach a cruising altitude of 38,000 feet is notably longer, about 40 minutes for the A340-300 compared to just 25 minutes for the 787. These longer takeoff and climb times not only affect flight schedules, but also have operational efficiency implications, such as increased fuel consumption and extended crew duty times. The result is a less competitive aircraft that struggles to match the performance and efficiency of its peers. The root of the A340-300's underperformance can be traced to its engines. This aircraft is powered by 4 CFM56 engines, a model that is widely used and highly popular with over 33,000 units built. However, the CFM56 was originally designed for smaller aircraft and has a diameter of just 72 inches, making it the smallest engine used on any wide-body aircraft. In stark contrast, the engines on the Boeing 787 boast a fan diameter of 111 inches, which is over 50% larger. This significant size difference is a key factor in the A340-300's struggles to match the performance of its peers. The smaller engines not only limit the A340-300's thrust, but also contribute to higher operational costs. Longer flight times and increased fuel consumption are direct consequences of the inadequate engine size. The CFM56's design, while efficient for smaller aircraft, simply doesn't provide the necessary power for a wide-body jet of the A340-300 size. This mismatch has resulted in an aircraft that, despite its impressive range and capacity, underperforms in crucial areas like takeoff, climb, and overall fuel efficiency. Interestingly, the CFM56 wasn't Airbus's first choice for the A340-300. Initially, Airbus planned to use the IAE Superfan, a revolutionary engine that incorporated advanced composite materials, contoured titanium fan blades, and a geared turbofan architecture. This innovative design promised a 20% improvement in fuel efficiency, which would have been a game-changer for the A340-300. Unfortunately, the Superfan project faced insurmountable technical challenges that prevented it from becoming commercially viable. The failure of the Superfan project forced Airbus to adopt the CFM56 as a temporary solution. This decision resulted in significant performance compromises for the A340-300. The anticipated advantages of the Superfan, such as superior fuel efficiency and thrust, were never realized. This setback not only affected the A340-300's performance, but also impacted Airbus's ability to compete with Boeing, which was advancing rapidly in engine technology. The loss of the Superfan project meant that Airbus had to rely on an engine that was not ideally suited for their wide-body aircraft, resulting in the underperformance that we see today. With the Superfan out of the picture, Airbus had to make several design concessions to meet the A340-300's performance promises. The smaller CFM56 engines, while offering some fuel efficiency, lacked the necessary thrust, leading to extended takeoff rolls and slower climb rates. To compensate for the reduced thrust, Airbus increased the A340's wingspan by 2.6 meters. This modification helped generate more lift, but also added weight to the design, further reducing aerodynamic efficiency. Consequently, the A340-300's range decreased by about 1,000 nautical miles, and its cruising speed dropped to Mach 0.82, with optimal efficiency at Mach 0.78. This speed reduction adds over an hour to long-haul flights, impacting flight schedules and passenger experience. These design changes not only affected the plane's performance, but also its marketability and operational costs for airlines. The additional weight and reduced efficiency made the A340-300 less attractive compared to more modern, efficient aircraft like the Boeing 787, which could offer better performance and lower operational costs. Recognizing the limitations of the CFM56 engines, Airbus opted for more powerful Trent 700 engines for later A340 variants, like the A340-500 and A340-600. These engines are significantly larger and more powerful, allowing these variants to produce up to 244,000 pounds of thrust, nearly double that of the A340-300. This increase in power enabled the newer variants to achieve better takeoff and climb performance, making them more competitive in the market. However, this boost in performance came at the cost of higher fuel consumption. The more powerful engines required more fuel, leading to increased operational costs and environmental impact. Despite these efforts, Airbus struggled to find the right balance between power and efficiency for the A340 family. While the newer variants did improve performance, they also introduced new challenges, particularly in terms of fuel economy and emissions. These factors contributed to the A340 family's mixed legacy in the aviation industry, highlighting the difficulties of designing a versatile and efficient wide-body aircraft.